Now let's talk about the specific immune response, which gives us long-term protection from certain pathogens. The specific immune cells not only recognize pathogens, but also form a memory of them. However, it responds more slowly than the nonspecific system, responding in hours to days instead of minutes. Cells in the specific immune system recognize antigens, which are molecules or fragments of molecules, usually from a pathogen, that induce an immune response. When the cells recognize an antigen, they produce proteins called antibodies. Antibodies bind to specific antigens and act as a flag, making them easier for the immune system to recognize. When you don't have an infection, the levels of antibodies in your blood are fairly low. But during an infection, their production ramps up. So in this graph, you can see that at the time of infection, there are very low levels of these three different antibodies. But after infection, more are produced, and there are much higher levels of the different antibodies. After the infection is cleared, the levels drop again, but some antibodies remain in the blood, keeping a memory of that antigen. Because antibody levels change in the body in response to an infection, we can use their levels in the blood, which we call antibody titers, to help identify if someone has an infection, and even sometimes how recent that infection is. The antibodies in this graph are produced in response to infection with the bacterium that causes Lyme disease. They each respond differently to the infection, so looking at the concentrations of each of these antibodies can help us estimate when the infection may have occurred. The fact that our immune system makes a memory of pathogens allows us to protect ourselves using vaccines. Vaccines are weakened or harmless forms of a specific pathogen that are administered to the body. When we introduce that pathogen containing antigens, the body responds by producing antibodies for those antigens. So we are able to develop some immunity without actually becoming infected. But producing vaccines is challenging because many pathogens change very rapidly. You probably know that you need to get a new flu vaccine every year. This is because the influenza virus has a very high mutation rate. Each time it mutates, its antigens change, making it harder for the immune system to recognize them. Antibodies are produced by leukocytes in the specific immune cells called B cells. Antibodies are shaped like a Y. The top of the Y is variable and differs between antibodies for different antigens. It needs to have just the right shape to recognize and bind to that specific antigen. Antibodies may be free-floating in the body fluids, or they may be found attached to the outside of the B cells. But antibodies don't just recognize pathogens. They can recognize all sorts of foreign material in the body. This includes things like pollen, toxins, and non-self cells. So your immune system may develop antibodies to pollen, causing you to have an immune response to that pollen. Or if you get an organ transplant, the immune system may recognize those cells as not being part of your body and attack them. Again, antibodies are specific. They bind to a very specific antigen. This allows them to help in the immune system's attack in several ways. One way is phagocyte signaling. When an antibody binds to an antigen, it acts as a flag, marking it so that phagocytes like macrophages or neutrophils can easily recognize and engulf it. Antibodies can also cause antigen clumping. When many antibodies bind to antigens on a pathogen, it can cause them to clump together, This also makes it easier for phagocytes to efficiently engulf and remove the pathogens. Another way antibodies help fight pathogens is by preventing them from entering cells. By coating the surface of a pathogen, antibodies can make it harder for those pathogens to get inside cells and infect them. And finally, antibodies can also help fight infection by recruiting complement proteins. Complement proteins are proteins produced by the immune system that poke holes in pathogens to destroy them. Now pause and answer these two questions from participation assignment 14. We're going to talk about two different types of cells in the specific immune system, both of which are lymphocytes. Lymphocytes are white blood cells in the blood and lymph fluid that are covered in antigen receptors. These receptors bind to specific antigens, allowing the lymphocytes to recognize them and mount a specific attack. We already mentioned B cells, which produce histamine. B cells are produced in the bone marrow and mature there, so you can remember B for bone. In addition to histamine, they also produce and release antibodies. T cells are another type of lymphocyte. They are also produced in the bone marrow, but they travel down to the thymus, T for thymus, where they mature and destroy infected cells. Again, lymphocytes are very specific in the antigens they recognize and the pathogens they can attack. They need to have the right receptors on their cell surface to bind to those antigens. There are two types of specific immune responses. The specific immune response can attack either pathogens in the body fluids, which is known as humoral immunity, or if pathogens get inside cells, it can also attack pathogens within those cells. This is called cell-mediated immunity. We have antibodies for many different antigens circulating in our body fluids all the time. This humoral immunity helps recognize and destroy those pathogens, hopefully before they enter our cells. But cell-mediated immunity allows us to attack pathogens that have already invaded cells. In cell-mediated immunity, T cells recognize infected cells by the antigens on their surface. The T cells then destroy the infected cells, which hopefully then also kills the pathogens inside. The specific immune system can launch two types of attacks, depending on whether it has encountered that pathogen before. The first time you are infected with a pathogen, your body launches a primary response. When you are reinfected, it launches a secondary response. The primary response happens in 4 steps. First, the pathogen is recognized as a foreign body. This happens when antigen receptors on the lymphocytes bind to the antigens from the pathogen. Next, the body increases the number of lymphocytes to strengthen the response. When a lymphocyte binds to an antigen, it starts dividing and making clones of itself, so there are more cells available to fight the infection. Next, some of the B cells and T cells, called effector cells, start attacking the pathogens. The B cells do this by releasing antibodies, and the T cells attack the pathogens or infected cells. But some of the B cells and T cells don't attack. Instead, they become memory cells. They stay in the blood and lymph, ready to recognize an antigen if another infection occurs. Because these memory cells stay in the body, the second time a pathogen is introduced to your body, you can have a much more rapid response. You may not even develop symptoms during a secondary response. If you look at this graph, you can see the difference in antibody levels after the first time you are exposed to chickenpox and the second time. The first time, your body has to launch a primary response. It takes some time for the immune cells to recognize the pathogen, produce antibodies, and fight off the infection. But those memory cells stay in the body fluids ready for the next time you are exposed. On that second infection, the body launches a secondary response, which happens much more quickly. So antibody levels increase rapidly, destroying the pathogen before it can make you sick. But our immune systems are not perfect, and they can make mistakes. Allergies occur when our immune system has an inappropriate response to something that is not harmful. The big 8 are the 8 foods humans are most likely to develop an allergy to. Allergies develop when the immune system produces antibodies to an allergen, which is an antigen that is not disease-causing, but causes an allergic response. The first time someone is exposed to an allergen, the body has a normal humoral response, and there is no allergic reaction. This is because the body doesn't yet have antibodies to that allergen. However, during that first exposure, the immune system may develop antibodies specific to that antigen and form memory cells. The antibodies bind to the surface of mast cells, making them sensitive to the allergen. Then, when the person is exposed a second time, the body is primed for an allergic response. So during that second exposure, the allergens bind to the antibodies on those mast cells, which begin to release histamine. Histamine causes inflammation and leads to allergic reactions. Autoimmune diseases are another way our immune system can make mistakes. An autoimmune disease occurs when the immune system thinks cells in our own bodies are foreign. Type 1 diabetes is an example of an autoimmune disease. In type 1 diabetes, immune cells destroy cells in the pancreas, decreasing the pancreas's ability to produce insulin and regulate blood sugar.